This is video number 3 for sections 6.4, 6.5, and 6.6, factoring trinomials. We're still going through our overall factoring strategy. Remember, step 1, pull out the GCF. Step 2, count the number of terms you have remaining, because that tells you where to go next. In this video, we'll consider the situation where you have 3 terms, in other words, where you have a trinomial. I have 2 methods to show you. These are not categories, these are methods. Any of the problems could be done using method 1. Any of the problems could be done using method 2. I'm showing you both of them so that you have a choice. Of course, it's possible that you'll end up with a trinomial that's prime, that doesn't factor, in which case, of course, neither method will work. The first method is called the reverse FOIL method, otherwise known as good old-fashioned trial and error. And the idea goes like this. When you see a trinomial and somebody wants you to come up with the original multiplication problem, you want your brain to think, I know where this came from. This was somebody's FOIL problem. And somebody went ahead and FOILed it all out, and this is what they came up with. And in fact, I know where these pieces came from. The F part of the FOIL, the first part, always creates this front item. The outer and the inner guys, the OI part of the FOIL, that always creates this piece in the middle. And then the last terms multiplied, that always creates this one at the end. And so if I want to factor this, I just need to try to reconstruct that original FOIL problem. All right, so I'm going to give myself an extra big set of double parentheses here. And the idea is I'm going to list out some possibilities and use some trial and error to figure out the original multiplication problem. Start with the F part of the problem, the 2x squared. All right, I know that that comes from 2 guys here at the front that get multiplied together. Well, the great thing about 2x squared is there is only one multiplication problem you can write down to get that answer. It is 2x times x. There is no other choice. That's fantastic. I would say the trial and error method works best when the numbers are relatively small, because then there aren't very many options. The second place I'll go is to the L part, because I know that that number there comes from the 2 last terms in the original FOIL problem. I'm not going to even worry about the signs yet. I know I need it to be a -4. I'm just concentrating on the 4. Well, what are my options? Maybe it's 2 times 2. On the other hand, maybe it's 4 times 1. Or lastly, maybe it's 1 times 4. That's it. There's no other way to make a 4 than those 3 options. Now I just have to decide which one of them is correct. Well, that's where the OI part comes in. Somehow I'm going to need to make a 7 out of the outer and inner multiplications, right? It's the outer and the inner multiplications. That's where that -7x came from. Again, I'll worry about the negative part of that in a minute. You could even list the OI options out here on the side for each of my 3 candidates. For example, if the top numbers are correct, the outer multiplication would be 4x, and the inner multiplication would be 2x. Can I make a 7x out of that? I don't think so. How about the middle row? Outer would be 2x times 1. Inner would be 4 times x. I don't think that's going to work. Bottom row, outer would be 2x times 4, 8x. Inner would be 1 times x, which is 1x. And as soon as I get there, I think to myself, I'm pretty sure I can make a 7 out of that. Now here's where the signs come into play. Specifically, I need to make a -7 there in the middle. How can I do that with an 8 and a 1? I think I would need a -8 and a +1. -8 plus 1 is going to make -7. Well, if I need the 8 to be negative, I believe I would need a minus sign here. There's my -8x, and a plus sign here. There's my +1x. I believe we've just found our answer. We're saying that the original multiplication problem is that bottom row. 2x plus 1 times x minus 4. A quick foiling would show you that we are correct. 2x times x, 2x squared. There's those middle guys, the minus 8x and the plus 1x. That gives me the negative 7x. 1 times negative 4 is negative 4. That's the trial and error method. I would encourage you to use the trial and error method, particularly when the numbers are small. It does tend to be the fastest way. Let me give you one final tip here as well when you're listing out your possibilities. We didn't really talk about GCF, but if you go back to the original problem, you'll notice there is no GCF to pull out to the front. Well, if that's the case, you're not going to create a GCF in one of these parentheses later. I can reject this top row right off the bat because it would be 2x plus 2. 2x plus 2 has a GCF, so there's no way that that could be correct. Look at the second row. 2x plus 4. 2x plus 4 has a GCF. There's no way that could be correct. Really, the only option even worth trying in this one is that bottom row, which of course produced the correct answer. The trial and error method is great, though some students feel like it's just not systematic enough, and they prefer something a little bit more organized. Well, that takes me to this other method, which we affectionately call the Xbox method. Now, I'm going to need to do a little bit of setup in order to explain this method for you. This method is related to the box that we learned about for multiplying polynomials. Let me show you a couple of examples because I need to point out a pattern and then we'll get to the method. So this first example says go ahead and multiply, do this FOIL problem using the box. So go ahead and do that. Here's what you should have gotten. 2x squared plus 7x plus 6. Now it goes on to say that there's an interesting pattern you can see when you use one of these boxes. In order to see the pattern, you need to do some diagonal multiplication as shown in this illustration. So if you go back up to your box, if I multiply that way diagonally, I get 12x squared. If I multiply this way diagonally, I also get 12x squared. I get the same thing. Now we need to make sure that's not just a coincidence. Let's go down to this other example here. Take a minute and also multiply that using the box. Here's the answer that you should have gotten. Well, let's look for that multiplication pattern again. If I multiply this way diagonally, I get 42x squared. If I multiply the other way diagonally, I also get 42x squared. This is not a coincidence. This happens every single time you use the box. Well, that pattern turns out to be the key to what's called the Xbox method. So let me come down here to this fresh example now, and we'll talk through the steps of the Xbox method. You can see the problem. Here's a fresh polynomial. We're being asked to factor it. Step 1, pull out the GCF. You can examine this. There's nothing that I can pull out. Step 2, count the terms. 1, 2, 3 terms. It's a trinomial. I could factor this using trial and error. It would take a little longer than the last one we did because 6 has multiple possibilities and 10 has multiple possibilities, but it is possible. But let me go ahead and demonstrate the Xbox method, and you can see down at the bottom here the list of steps that we're going to follow. All right, the idea is, remember that front guy? I know where that comes from. That comes from the F part of the FOIL. It comes from that upper left box, so I can always put that in there. Similarly, the 10, I know where that comes from too. That comes from the L part of the FOIL, which is always in that lower right box. You can check those earlier examples we did with the boxes. The tricky part, though, is the negative 19, right? That's the part that's from the OI part of the FOIL problem, the outer and the inner. I know there's going to be 2 terms in these 2 boxes, and if I add them up, I'll get the negative 19x. I'm just not sure what they are right now. One thing for sure, though, the coefficients will add to negative 19. Well, that's where the giant X comes in over here. See this little plus? I'm going to write down for myself the fact that I'm looking for 2 numbers, and I know those 2 numbers are going to add up to negative 19. Here's the other thing I know about those two numbers. Remember that diagonal pattern that we observed? I can see that this way diagonally, I'm going to get 60x squared. Well, that means this way diagonally, I have to get the same. So whatever those two coefficients are, when you times them, when you multiply them, you have to get 60. The secret to this problem is finding two numbers that multiply to 60 but add to negative 19. You can do this very systematically. Just start listing all the numbers that go into 60 evenly. Go in order. You can use your calculator to help you. Does 1 go into 60? Yes, 60 times. Just stop as soon as you can make a negative 19. I don't think I can with those. Does 2 go into 60? Yes, 30 times. Does 3 go in? Yes, 20 times. Does 4 go in? Yes, 15 times. As soon as I get to there, I think, wait a minute, I'm pretty sure that I can make a negative 19. In fact, all I would need to do is put a negative in front of each of those two numbers, and I have it. Negative 4 plus negative 15 makes negative 19. Negative 4 times negative 15 makes positive 60. All the negatives and positives have to work out. Well, that means those two numbers must be the coefficients I was looking for in my box. Now I know how to split up that negative 19x. I split it up as negative 4x and negative 15x. Don't forget the x's. You can always check the diagonal pattern, 60x squared, 60x squared, just like I wanted. By the way, I could have switched places with these two boxes and I would still be able to get the right answer as long as one of them has a negative 4x and one of them has a negative 15x. Okay, where do we go now? Well, remember, the original FOIL problem is going to end up here around the outer edge. So pay attention to these next steps. This is really the critical part. What you do next is you go to the top row, just the top row, and you pull out the GCF. Well, let's see. Biggest number that goes into both 6 and 4 would be 2. As far as the x's, it looks like I'm limited by the second guy, but I can at least pull out 1x. I've just pulled out the GCF. It has to be the GCF or this won't work. How do you fill in all the rest? Well, you simply think about the multiplication process. Whatever goes up here, when you multiply that times 2x, you have to get 6x squared. Well, that would mean a 3 and an x. 3x times 2x is 6x squared. How about this space? Well, whatever you have here times 3x has to make negative 15x. That's going to be negative 5. Finally, whatever goes here times the negative 5 has to make positive 10. Well, that would be negative 2. I simply thought about reversing the multiplication process to fill in those items. What you have now across the top and on the side are the pieces of the FOIL problem. The final answer to this problem is 3x minus 2 times 2x minus 5. A quick FOIL multiplication would easily convince you that we have the right answer. These problems are very, very easy to check. This is a very, very systematic method and one that you can get quite good at and quite quick at if you practice it sufficiently. One thing you might want to do now is go back up to that example where we used the trial and error method and try it over again with the Xbox method. Just mimic the steps that we just did right here and you will see that you can also get the correct answer.